So during this lesson, we'll be talking more about linear functions and the function notation, specifically how to write functions in 4 ways. So this first part, this is sort of a mini lesson explaining the main difference is for the output, instead of putting y, put f of x, like this. So, or in this example here, you could use different letters. For example, this is d of g equals m times g plus b. Here, so what's important to notice here is for the output, it's this thing where it's a letter, then parentheses, then a letter inside. And this letter inside here is the input. So why is that useful? Well, here, look at this, mg plus b. Which of these letters are the input? Well, if I check the output value, I see a g's in here. So g must be the input. Another thing is you can put other values for the input and use that to calculate, and we'll see that in a minute. So that's a little bit about function notation, and we see how we apply it. So again, g is the input, d of g is the output. So let's go through this first example. Let's go through this together. So the description of the situation is here. And you're going to express as a table, symbolic representation, that's our function notation, and a graph. So let's read the description. Mary is riding her bike to visit her grandmother. She has already traveled 3 miles, and she can travel 4 miles per hour. Express how far she can travel if t is the input for time, and m of t is the output for miles traveled. So right here is very important. Our input is t, our output is m of t. So when we write that, we get this. So t is the input, m of t is the output. Input is t. And you could like make a drawing for this, or you could just underline it and just make it clear. Be better if there was a line down the middle, but that's okay. So let's have some input values. We have 0, 1, 2, 3, 4, 5. That's probably good. And let's think this through. So first, after 0 hours, she's already traveled 3 miles, okay? And we think after 1 hour, she's traveled 4 more miles, so that's 7 miles. In another hour, it's still 4 more. 4 more again. Each hour, she travels another 4 miles, so we just add 4 to the previous value. So we start with 3, and we end with 23. And then we add 4 each time. So for a symbolic representation, right, we have m of t equals mt plus b. T is our input variable. So we think we need m, which is slope, and b, which is our initial value. So b is initial value. What does that mean? The output when the input is 0. And that's always what it is, initial value. You also hear y-intercept, okay? And that value is 3. That's how we do that. And you can write all this, but the final answer is what's most important. The initial value is 3, or y-intercept. And then the m value, in this case, lowercase m, is the slope. Slope is also known as rate of change, how much the output changes when the input increases by 1. So that value is, lowercase m is 4. So now we can write our equation. I'm going to make this lowercase m. So that means m of t equals 4t plus 3. So again, we just replaced the slope and our initial value or y-intercept. I'm going to call this y-intercept because we call it y-intercept a lot. So 3 is that initial value, and 4 is the slope, how much we change by. That matches the table and the graph. And then, symbolic representation, then we make the graph. So I already put a graph here. We're going to try something, see if you can edit it. If not, draw your own picture. If you can edit it, though, what I'm going to do first is I'm going to just put that there so I know what I'm talking about. Maybe label this. The output is T. The input is, whoops. Sometimes it's hard to get this correct. The input is M of T. I'm just labeling my axes, right? So once I labeled that, I think, okay, my initial value is 3. So that's right here. Right here is, right there is 3, right? The point is 3, 0. So I have it go through this point, and each time it goes up by 4. So I start here, and I make the line go up 4. 4 more than 3 is 7, and I draw the line up. And oops, I can also make it go negative. BB. Stretch out the end of the line so it keeps on decreasing. And that's how we draw our line. Linear functions always make a straight line, so this line represents our function. Save and close. So these are 4 different ways of representing a function: description, a table, symbolic representation, and a graph. And all of them represent the same information. So here's some questions. I'm going to answer these 2 questions, then you're going to practice this yourself. M of 3, what does that mean? That means the input is 3, right? So M of 3, let's see. You can look at the table. M of 3 is 15, okay? So we could just write 15, or we could look at the graph, or we can use our symbolic representation, which is up here. You plug in 3 for T, add 3, that's 12 plus 3, which equals 15. So the answer is 15. What does that mean in our situation? And notice I'm just typing everything here. This describes the situation after 3 hours. Mary has traveled 15 miles. I don't know if anyone actually wants to travel that far on bike, but a lot of people do. Let's just say, what does this mean? M of T equals 7. In the situation, that means 7 is the output, right? The output equals 7. The output equals 7. So this means this is asking what is the number of hours it takes to travel 7 miles, right? So the unknown here is T. The input is the unknown. So we don't know the number of hours. We know it's 7 miles, so we ask how many hours does it take to get to 7 miles? All right. So that's that. So we did the 4 representations and then answer some questions. Same thing here. You're giving a situation. You're going to represent it in different ways, answer a question. Same thing here. For number 3, though, you're given a table and you have to think a little bit, come up with your own description, come up with your own situation. It could be anything you want as long as it fits the information given. Okay, then you do it the other way and you answer some questions. You represent it in the other ways. So that's about it. It's just some practice seeing we can represent the same information in different ways. We'll be exploring this throughout the whole course. but we're just starting with their linear functions. So I hope this made sense. Again, please ask if you have any questions. Of course, we'll go over this during our online meetings, but make sure to attempt the problems, and again, post either to email or the Google Classroom if you have any questions, or ask them during the online meetings. All right, good. Hope that goes well, and I will talk to you later.